Have you ever stopped to think about the changes happening all around you? Let me ask you something. When ice melts into water, has its chemical identity changed? Or is it simply a change in form? If you tear a sheet of paper, is it still paper? Or has it been fundamentally altered? When iron is magnetized, has its substance changed? Or only the alignment of particles? When leaves change color in autumn, is it only appearance or a chemical process? Can something stay the same, even when it looks completely different? And at what point does a thing become something else entirely? Every day, matter undergoes change. But behind these everyday processes lies a fundamental question in science. What kind of change is truly occurring? Is the chemical identity of the substance preserved, or has it transformed into something entirely new? Understanding the difference between physical changes and chemical changes is more than just a textbook exercise. It's foundational to fields like chemistry, biology, material science, and environmental studies. Today, we'll explore how scientists classify changes in matter, identify their characteristics, and use observable clues, like energy transfer, color shifts, or the formation of gases, to distinguish between reversible physical processes and irreversible chemical reactions. So now we know that matter can change, sometimes just in form, sometimes in identity. But before we dive into examples of changes, let's first clarify a fundamental concept. What exactly is a property of matter? Properties are the characteristics that allow us to identify, describe, and distinguish one substance from another. Some properties are readily observable, such as color, shape, or texture. Others require measurement tools, including temperature, density, or conductivity. Matter has properties that are physical or chemical. First, let's consider physical properties. A physical property is a characteristic of matter that can be observed or measured without changing the substance's chemical identity. Common examples include density, color, hardness, melting and boiling points, and electrical conductivity. Some properties, like color or density, can be observed directly. Others, like melting or boiling points, only reveal themselves when matter undergoes a physical change. Having identified physical properties, we can now ask, what is a physical change? A physical change is a transformation in which a substance changes its form, state, or appearance without altering its chemical composition. No new substances are formed, and the molecules themselves remain unchanged. When ice melts into water, it undergoes a change in state, but the molecules remain H2O. Other examples of physical changes include boiling water into steam, dissolving sugar in coffee, magnetizing or demagnetizing metals, and grinding solids into powders. In each case, the substance changes in form, state, or appearance, yet its chemical composition stays the same. But some changes go deeper. What if it transforms into something entirely new? That's when chemical properties become important. A chemical property describes a substance's ability to undergo a chemical change, producing one or more new substances with different compositions and identities. Examples include flammability, toxicity, acidity, reactivity, and heat of combustion. Chemical properties are revealed when a substance undergoes a chemical change, transforming into a new substance with distinct composition and properties. So, let's now consider chemical changes. A chemical change, also called a chemical reaction, occurs when one or more substances undergo a fundamental transformation, forming new substances with different chemical compositions and properties. Bonds are broken and new bonds are formed, producing matter with a new identity. Indicators of a chemical change include the evolution of gas, unexpected color changes, the release or absorption of heat or light, and irreversible changes in composition. These observable signs help identify when a substance has undergone a chemical transformation. Examples of chemical changes include the formation of rust, where the resulting substance is different from the original iron, oxygen, and water. Food being digested to form new molecules, and some metals reacting with acids to release hydrogen gas. In each case, the substances undergo a transformation that produces matter with a new chemical composition. Now that we've covered properties and changes, we can refine our understanding further. Some properties depend on how much substance you have, while others remain the same regardless of quantity. This brings us to intensive and extensive properties. First, intensive properties. An intensive property is a characteristic of matter that does not depend on the quantity of the substance present. It is a property of a substance that stays the same regardless of the amount present. Intensive properties are like the color of paint. No matter how much you pour, the color stays the same. Common examples of intensive properties include density, color, temperature, boiling point, melting point, and hardness. Now, extensive properties. An extensive property is a characteristic of matter that depends on the quantity of the substance present. Its magnitude changes proportionally with the amount of material. Extensive properties include mass, volume, and total energy. Understanding physical and chemical changes allows scientists such as chemists, biologists, materials scientists, and environmental scientists to predict outcomes, control reactions, and design effective processes. Let's bring it all together and see the big picture. Physical properties and changes involve characteristics or transformations that do not alter a substance's identity, while chemical properties and changes involve the formation of new substances. Intensive properties are independent of amount, and extensive properties depend on quantity. Together, these concepts provide a framework for understanding and classifying matter. Enjoyed this video? Like, subscribe, and hit the bell for more chemistry content. Until next time, stay curious and keep exploring.